happens when the field is applied, then the ions are gets displaced. So due to the displacement of ions, ionic polarization arises in the material. Since ions are heavier than electronic cloud. Okay, so that ions are heavier than electronic cloud, so that the time taken for displacement is larger. So it takes a very much larger time to displace. Okay, the frequency with which ions are displaced is of the same order as lattice vibration frequency, that is 10 to the power of 13 hertz. This means that for optical frequency, that is optical frequency, the ions do not respond. At optical frequencies, the ions do not respond. As the time required for lattice vibrations is nearly 100 times larger than the period of the applied voltage at optical frequencies. So that at optical frequencies there is no ionic polarization. If the frequency of the applied voltage is less than 10 to the power of 13 hertz, then only the ions respond. But at the optical frequencies, that is at 10 to the power of 13 hertz of frequency, we have both electronic polarization as well as the ionic polarization responding. Okay, now coming to orientational. Orientation polarization. Orientation polarization is even slower than ionic polarization. The relaxation time for orientation polarization in a liquid is less than that in a solid. For example, the relaxation time for orientation polarization is 10 to the power of minus 10 seconds in liquid. Liquid propyl alcohol, while it is 3 into 10 to the power of minus 6 seconds in solid ice. Orientation polarization occurs when the frequency of the applied voltage is in the audio range. Okay, orientation polarization అనేది రైజ్ అవ్వాలి అంటే మెటీరియల్ లో ఈ ఫ్రీక్వెన్సీ అప్లై చేసిన వోల్టేజ్ ఫ్రీక్వెన్సీ అనేది ఇట్ ఈస్ ఇన్ ద ఆడియో రేంజ్, then only orientation polarization occurs. Okay, orientation polarization is even slower than ionic polarization, and the relaxation time for orientation polarization in a liquid is less than that in solid. Relaxation time. For example, the relaxation time for orientation polarization is 10 to the power of minus 10 seconds in liquid propyl alcohol, whereas in it is 3 into 10 to the power of minus 6 seconds in solid ice. Then orientation polarization occurs when the frequency of the applied voltage is in the audio range. And next one is space charge polarization. Space, that is the fourth kind of polarization. Space charge polarization is the slowest process, as it involves the diffusion of ions over several interatomic distances. The relaxation time for this process is related to the frequency of successful jumps of ions under the influence of the applied field. A typical value being 10 to the power of 2 hertz. Correspondingly, space charge polarization occurs at power frequencies that is in between 50 to 60 hertz. The figure 12 illustrates all 4 types of polarization at different frequency ranges. At optical frequencies, that is 10 to the power of 15 hertz, electronic polarization alone is present. At 10 to the power of 13 hertz range, ionic polarization in addition to electronic polarization occurs. At 10 to the power of 6 to 10 to the power of 10 hertz range, contribution due to orientation polarization gets added, while at 10 to the power of 2 hertz range space charge polarization also contributes. Okay, so then ఈ diagrammatic representation గురించి, diagrammatic representation of four kinds of polarizations as well as applications of dielectric materials. సో రేపు క్లాస్ లో చెప్పుకుందాము, ఇప్పుడు ఇది అవ్వదు కదా, టైం అయిపోతుంది. Polarization versus frequency. So optical frequency, infrared frequency, radio frequency, audio frequency, power frequencies. సో ఇలా స్లోగా పోలరైజేషన్ అనేది ఇంక్రీజ్ అవుతూ ఉంటుంది. ఓకే, సో రేపు క్లాస్ లో చెప్పుకుందాం.